Welcome to June 22nd's LeetCode Challenge. Number of matching subsequences. Given a string S and an array of strings words, return the number of words at index I that is the subsequence of S. A subsequence of a string is a new string generated from the original string with some characters can be more deleted without changing the relative order of the remaining string characters. For example, ACE is a subsequence of A, B, C, D, E, right? If you get rid of B and D, then you have the remaining ACE. So here's an example here. So you have a string given A, B, C, D, E, and you have a number of words. So can you make what are the numbers of the three substrings you can make from the sequence of given here? So for instance, you could make A by deleting B, C, D, and E. You cannot make BB because there is only one B in the given string. However, you can make ACD by deleting B and deleting E, then you get the remaining. And then, of course, we've seen here before, ACE can be made by deleting B and D. Okay, how are we going to approach this? So, as you can see some of the constraints here, if we do a brute force or naive approach, we'll be doing a we'll be iterating through each word, through each character of each word to match them up. And we don't want that because that's probably going to take a long time. You can see the 5 to the power of 10 to the 4th is a very large number. And if you any power to that will be a very large time complexity. So in order to do this, let's do a let's perform a just an iterative search through it using for loops, and we're gonna find each character in each we're gonna find each letter, see if we can make a substring out of the string given from the set of words. And then that's gonna be our approach. So my first initial reaction or instinct to this is to be able to do a for loop for it, and then we're gonna also define. So what first thing we have is let's initialize our counter, which is going to count how many numbers of substrings you can make from the word list given our string S. So we're going to do count initialize to 0, assigned to 0. So for each word, for word in words, what we're going to do is that we're going to initiate our first count or index to I. So we're going to search through each index of each word to make sure that they are that that's what we're looking for, and they can make a substring out of it. So for each element J in word W, what we're going to do is that we're going to do a conditional statement here. So if the index J is in the string that we're given from the very start to the very end, so we're taking a slice of the string. If that's the case, then what we're going to do, we're just going to assign I to be the index of the string. So find the index character of the string at J I location plus 1, because we are taking the slice of it afterwards. We want to be inclusive. Else, if this is not the case, we're going to break from it. And then we have a for statement here. So what we're going to do is we're going to else. Yeah, if we break from it, we go else count plus 1. That means we are able to make our substrings with words from our string set S. And at the end of this, we want to return our count. All right. Let's see if this is going to give us what we need. All right, let's submit that. Okay, accepted. So time complexity would be big O of if we call this m, so m times the length of the words n log. So we're doing a for loop here for each word in words. So it will be m times the each index in word. So m times n times the log of the n value. So yeah, it would be big O of m times n log n. And for space complexity, we have big O of n, because we are keeping track of the count, and that's the only thing we're incrementing, so n times. So in terms of time complexity, it's still quite large, and it is accepted. Let's see if we can make this a little bit quicker. So how we're going to go about doing that. So we'll leave this the same, and we'll leave this the same. So instead of using a for words in words, how about we do a little trick here. So for word and character, and we're going to use a function here, counter for words dot item, items I should say. All right, we're going to use a method here. Another method called a counter, so which this keeps track of counts each word and assigns it to an element to an item. So therefore, we can cycle through our word and character at the same time. Then what else do we want to do? We want to keep the index the same, index counter for j in words. So we're going to erase this for now. We're going to change this conditional statement up. So if this is the case, what we want to do is, it's already found. So our index j is already found. So what we want to do is, instead of doing index, what we want to do is actually find. Find. And else break, but if not I, then break. Else, it's not gonna be +1 again. It's gonna be plus count right here. All right, and let's run the code and see if this gets a little bit better. Finished. Let's submit it. All right, accepted. So this, using this method, you have to keep the count at the same time as you do a for loop. Actually, increases our time complexity quite a bit. To it will be big O of n log n, and time space complexity is still big O of n, which we're still keeping our count here. So otherwise, that's pretty much it. Have yourself a nice day.